ready? In case you don't know, our lesson today 1 hour 20 minutes. Okay, mentally prep all of you guys for learning. Okay, so we'll start off with parallel lines. The concept is pretty simple actually, but it really depends on whether you can understand the question or not. Okay, so in this topic itself, coordinate geometry, it can be a very easy topic provided that you are able to draw the correct diagram to support your solving process. Okay, so the first thing that we'll cover is this idea of angle of inclination. Okay. Right, so what is the angle of inclination? It is a very, very minor concept in our parallel lines topic. Okay, so how do we define the angle of inclination? So let's say I have a set of axes here, and I have a line. Okay, a straight line, a diagonal line, okay, that is outward sloping like that. And if I have another case, also a set of axes, okay, but I have a downward sloping line. The angle of inclination is being defined as the angle found between the line and the positive x-axis. Okay, what is the positive x-axis? We are looking at the positive direction of your x-axis, so therefore this is the angle that we're referring to. Okay, I'm going to label it as theta. Right? So it is the angle found between the line that we have and the positive x-axis direction. So for a downward sloping line, positive x-axis direction is there, so we're looking at the line, the angle being defined this way. Okay? So that is your definition of an angle of inclination. Just writing in words the definition for you. Angle that the line makes in positive direction. Okay, this might make more sense to you when we go into trigonometry next term. Okay, next term, it will be heavily loaded on trigonometry, right? Our Picasso. Okay, so we're going to extend our understanding of Picasso from what we learned in Sec 2. Alright? Now, why is it this angle of inclination is important? Okay, so the angle of inclination can tell us the gradient of the line. How does that happen? I'm just going to use the positive upward sloping line here. If I have an angle here, I can form actually a right angle triangle in this manner. Alright? Okay. What did we learn about tangent theta when we were in Sec 2? What's the definition of tangent in Sec 2? Opposite over adjacent, right? Your Picasso. Okay. Opposite over adjacent. Okay? So what is the opposite? In this triangle here, opposite refers to here, and adjacent refers to here. Okay? Now, what is our definition of gradient? What did we just learn about gradient? Rise over run, right? Okay, or y2 minus y1 over x2 over x1. But in simple terms, when we learned it in Sec 1, it's just rise over run. Referring to this right angle triangle, what is the rise actually? The rise is actually here, right? And then the run is your adjacent. So what can we say about this? We say here and can conclude that tangent theta gives us the gradient. Okay? if I do not know the angle, if the question did not give us the angle, there's no way for us to use this formula. Okay, so we have a lot of ways to find gradient now. Right? We know to use rise over run, for which we extend it to doing coordinate geometry, your y2 minus y1 over x2 minus x1. And now, if I know what is the angle of inclination, I can use this formula to find gradient, which is tangent theta. Okay? It can also apply to a downward sloping line, just that at this juncture, because of our understanding of trigonometry, we have not yet covered angles that are obtuse angle. Okay, so I'm going to leave it at this here, okay, and tell us that gradient is equal to tangent theta regardless of whatever angle that we're having. Okay, regardless whether it's acute or is it obtuse. Right? It will apply for downward sloping line as well. Yes. We don't have it reflex. We will not have it reflex because our definition of angle of inclination is always from the line towards the positive x-axis. So it will never end up becoming reflex. Okay? So it will either be an acute or an obtuse angle only. Right angle, it will still be tangent 90 degrees, so one. Yeah. Okay, tangent 90 degrees is undifferent. It will be a vertical line. Okay? Right, so let's try out one question. Okay, page 158, try one. Okay, we speak up. Okay, it says here that we want to find the acute angle. So this is our objective. And we're given that the line segment P and Q, the angle that we're trying to find is the one, okay, that is between the line segment and also the positive direction of the x-axis. So in other words, what we're trying to find is the angle of inclination. Okay, so with the coordinates given for P and Q, I can find out what is the gradient. Okay, I can find the gradient of the line PQ by using our formula. So 6 plus 3, 9 divided by 6. That will give us 3 over 2. Right? So with the gradient to be 3 over 2, since I'm trying to find out what is the angle, our gradient is also being defined to be tangent theta. So tangent theta is equal to 3 over 2. Hence, theta itself, we will press into a calculator, tangent inverse of 3 over 2, and that will give us an angle of 56.309. Okay, a reminder and also to inform the scholars, for angles in degrees, we leave it to 1 decimal place, not 3 as well. So that's the exam requirement. Okay, questions? Right, so angle of inclination is really just this concept only. How is it related to your gradient? Okay, the bigger concept when it comes to parallel lines is more about this gradient. How does it relate when it is parallel? be able to conclude same gradient. Likewise, if I have same gradient, I can say that they are parallel lines. Okay, so it's a two-directional thing, right? In more abstract concept-wise, if I say that the equation of one line is y equals to m1x plus c1, m1 and c1 being a number itself, and then another line that has the equation y equals to m2x plus c2, where m2 and c2 are just numbers. If I say that they are parallel, okay, what I can then conclude is that m1 equals to m2. Okay? So likewise, the other way around. Okay? So taking a look at try to. Determine whether AB and CD are parallel, and we want to give reasons to support your answer. How do we go about supporting or determining whether the lines are parallel or not? What will you do? Moses, what will you do? Find the what's it called? Okay, so it's called the gradient. So we find the gradient of each of the respective line segments and check whether it's equal or not. Okay, so gradient of AB. So we find out the gradient separately. So we have 5 minus 0 over 3 minus negative 2. How the answer should be presented. Alright, so you may want to just check. Okay. Next, I want to look at exercise 7.1, question 9. That's in your page. That's in page 161. It says that a straight line passes through a certain point that has a coordinates 4, -3, and makes an angle degrees, okay, with the positive direction of the x-axis. So I'm not going to write the rest of the question. Okay. We want to find out what is the equation of the line. Okay. So how will we be able to find out the equation of the line? What did we learn in our E-maths that helps us find the equation of a straight line? What must we have when we want to find the equation of a straight line? Yes, Yang Yi. What must we have to find the equation of a straight line? We did it in E-maths. It looked like I just counted Malay or something like that. Yeah. What do we need in order to find the equation of a straight line? We did it in E-maths in chapter 4.3 on equation of a straight line. That the equation of a straight line has the format of y equals mx plus c. I don't know what word I mean. Okay. So we learned it, right? Okay, y equals mx plus c. So we need the gradient and also the y-intercept, okay, in order to form the equation of a straight line. Right? So first thing, how do we find the gradient? It makes an angle of 45 degrees. So therefore, tangent of 45 degrees will give us the gradient. And that is equals to 1. Okay? By the end of this year, you need to know that tangent 45 is 1. Because there is a special angle for your trigonometry. Okay? So now that we found the gradient already, I now need to know what is the value of C. When we were doing E-maths, what do we have to do? We form our incomplete equation, right? M is actually 1, but we don't need to write 1x. We form our incomplete equation of y equals to x plus c. Then, because this line passes through the point 4, -3, I submit in okay, and then I can find the value of C to be -7. Okay, Yang Yi, I hope I managed to ring a bell. Okay. So we get y equals x minus 7. However, I want to show us a different way to find equation of a straight line. This is what I'll do in E-maths. Okay, but since we're all E-maths students over here, we can definitely level out. Okay, we know our gradient formula, right? Which is m, and that is your y2 minus y1 over x2 minus x1, whichever that you memorize it. Okay. Now, if I have the coordinates of one point, okay, so let's say x1, y1, I have those information. But what if I don't have the second point? Okay, instead of maybe y2 minus y1, okay, I'll just use a y, and then x2 minus x1, I'll just use an x. So I have these numbers. Okay, so in this case, I have 4 and -3. I do not know another point. Okay, my gradient I actually already know, which is 1. Okay, so what I can do is to kind of rely on my gradient formula. Okay, cross multiply and I will get this. Right? So another way to remember how to find the equation of a straight line would be to remember it as an equation like that. Okay, so I'm writing in reverse. So your y minus y1 is written here. So you can have y the y coordinate of one point equals to the gradient times x minus x1. Okay, so this definitely is much faster. I think I leave it up to you what you prefer, but from here onwards, I'm going to do it in this manner. Okay, I'm not going to do the incomplete equation and then after find this. Purely up to you what you prefer. I will accept it if you have decided to do this in your homework. Okay, but I'm going to present it in this manner. Okay, so I'm going to use this formula to help us to find the equation of a straight line. Okay, so from here, we will then be able to see that x minus 4 minus 3 equals to y, so y equals to x minus 7. Okay, you get the same thing. Okay, essentially you're getting the same thing. Right? Just that I'm not going to be writing this. Okay, so that's another way to go about forming your equation. Which is actually what you will likely see throughout your entire A-maths textbook as well. Okay? The reason why I have to introduce this because that will be what you see in your textbook. Your textbook does not present it in this manner. So to help you understand what is happening, okay, I'm explaining it over here. Right? We do another one. Okay? So let me write this formula. Okay, looking at exercise 7.1, question 6. Of the point where L meets the x-axis. Right? You may wish to draw a diagram to help you understand the question itself. Okay, that is what I will encourage you to. In your diagram, it may not need to be drawn to scale, but sometimes it is helpful that you capture the correct information. Okay? So we have this line x plus 2y equals to 6. If I change it to our y equals to mx plus c format, I won't be able to know whether is it upward sloping or downward sloping. Right? So in other words, when I make y the subject, I will get y equals to negative half x plus 3. So I know for sure now that my line is downward sloping. Okay? So to draw my diagram, okay, downward sloping line, y-intercept 3, so probably look something like that. Okay, so this is my line x plus y equals to 6. Right? Then y-intercept 3 lah. Okay, I have another line L, which is the main character over here. So this line is parallel to what we have just drawn and passes through 3, 4. Okay, so this is y coordinate 3 already. Therefore 3, 4 may be somewhere here. Hence my line L might look something like that. I hope I drew it with that parallel. Okay, parallel line. What the question wants is we want to find the coordinates whereby objective is to know what is this coordinate here. Okay, so I've illustrated for you what this question is asking. Any questions regarding that? Okay, so with the diagram itself, we now try to figure out what is it that we need to find in order to know the coordinates here. What will we need? What will we need in order to find this? Maybe we explore what is this first. What can I know about these coordinates already? Y is 0 and x is 0. Okay, so we don't know the x coordinate. Right? Since I know y is 0, if I can plot my y equals to 0 into somewhere, if I know this equation, okay, that will help me find the x, right? Alright? Okay, so the key question here is, how do I find the equation of this line L? Okay, so we need the equation of the line L. So you see, I'm trying to work backwards from the thing that we're trying to find. Okay, we're trying to find this point. I looked at it. Okay, what is it that we might know already about this point? And then in order to find the other part of this point, I actually need the equation of line L. Then I think in reverse further, okay, knowing the equation of line L, or rather, how do I find the equation of the line L? Okay, so any equation of the line, I must have the gradient, I must have the y-intercept. Just like even if I'm using this, okay, I need to know what is the gradient. I also need the coordinates of one point. Okay, so gradient, will I be able to know it? Yes, right? Because it is parallel. Do I know the one point that's found on this line? I do, right? Which is 3, 4. Okay, which I may not have indicated. Yeah. Okay. So with that understanding, we proceed with trying to solve it. We find the equation of the straight line. So first the gradient. I'll just rewrite whatever that I've written there earlier. So the gradient is negative half. So the equation of line L will actually be y minus away the coordinates here. Y coordinate equals gradient x minus 3. What I'm doing is this formula here. Okay? y1 and x1 must be a point on the line, and then after that m is the gradient. So this is the coordinates of that point. Okay, so now I will be able to get negative half x plus 3 over 2. And we have y equals to negative half x plus 5. Yes.
I understand how like y minus y1 equals to
It is derived from your gradient. Yeah. I just shift this x minus x1 over, isn't it a gradient formula? Okay. Okay, so now that we have the equation of the line, we want to find the coordinates of the x-intercept. So when y is equals to 0, we find that x will be equals to 11. Therefore, the coordinates answering the question will be 11, 0. Okay? Any questions? we're looking at perpendicular lines. Okay. So I hope we're all getting it for parallel lines so far. Right? Okay. I want us to take a look at try 3. Okay, about collinear points. I'm going to edit the question a little. Let's just directly show that the points are collinear. Okay, in our Emaths, when I introduce the collinear concept to you, okay, it's long, okay, please wake up. When I introduced the collinear concept to you, it was merely to find out, okay, the coordinate of the other point. Okay, so in our Emaths, we're going to do a lot of proving, a lot of showing. So in this case, we're trying to show that the points are collinear. Okay, firstly, what is collinearity? What does collinear mean? What does collinear mean? The 3 points lie on the same line, right? Okay, I don't care how the coordinates are like. Essentially, they lie on the same straight line. Okay, my points never draw very nicely. Okay, it may not be equidistant, right? But they must be on the same straight line. When we say that they are on the same straight line, what do we manage to compute out of that? The gradient of each of the line segment will be equal. Okay? But if let's say I go and find out gradient of let's say PQ and the gradient of QR and the number happens to be equal, what can we say out of that? Can we just say that they are going to be collinear already? How many of you think that if I see that the value, okay, is actually equal, I can immediately say they are going to be collinear? They are only parallel. Okay, so when we see that the gradients are equal, we can only conclude that they are parallel. We cannot yet say that they are going to be collinear. There is one more critical information that's needed in order to show that it is collinear. And that is to mention that both line segments share a common point. Okay, so in this case, because if I have done the working, they both are talking about the common point, okay, Q, therefore the 2 lines must be, okay, meeting in such a way that they are collinear. You understand? So you cannot just say gradient, see that they are equal, and then say that they are collinear. You can only say that they are parallel, but you cannot say that they are collinear. You need the extra information to be provided. That is the common point that is found between the 2 lines that we have in order to say that it's collinear. Okay, Jihan, what do you want? Okay. Yeah, so to present our answer, finding the gradient of PQ, it really depends up to you what is it that you want to find. You want to find PQ, QR, or PR, just as long as it's 2 line segments. Okay, so I've decided to choose PQ, so we have 12 minus 2 over 4 minus 0. That will be 10 divided by 4.5. Then you just choose another line segment. Okay, maybe we choose QR. So 2 minus negative 3 divided by divide by 2, so we will get 2.5 as well. Okay, so based on the things that we have found, we see that the common point is Q. So to end off, writing the conclusion, we provide the evidence. We say that since the gradient, or since gradient PQ equals gradient QR, Q is a common point. Therefore, P, Q, and R are collinear. the working and the conclusion regarding the gradient. Another one is